value of the taps. It's pretty, I think it's new. And also the gain control that fixes the gain of each delay cell could be set as new.
There is no prior work on the use of DLL on FFE delay control?
I don't think so, no.
In fact, for other applications, like we use DLL circuits to provide, as a replica, to provide delays. For
yeah, DLL has been used in
right, no, I'm not talking about DLL, I'm talking about to provide fixed delay, robust to PVT or anything using the DLL for other applications.
Sure.
So
this is the main purpose of using a DLL. Right?
Yeah, I understand, but what is really new here?
So I think the most important part of the work is the implementation of an analog LMS. Also, LMS is not done in this case. The on-chip LMS is not done in this case, in this way. On-chip usually is done in digital domain, so haven't been done in analog, as far as I know. And so I think the most challenging part was putting everything together and showing this.
No, there's no question that it is going to be a good engineering work. I'm talking about the scholarly kind of contribution that.
I would say that the analog LMS on chip, and some novelty in the delay cells are based on cherry per stage, which I modified it, add some stuff, and the DLL and also the gain control and the LMS. So the adaptive DFE was fabricated in a 0.10 micron IBM technology design kit. So to perform the measurements, a 4-layer test board was fabricated with FR4 panel, and the die was wire bonded to the board with boot bonding wires. Also there was a cavity built in at the center of the chip to reduce the bonding wire lengths, so minimizing the parasitic effects of the bonding wires. I used SMP connectors for high-speed IOs and also the 2.5 gig DLL reference input clocks. So here's the micrograph of the chip and with bonding wire, so it's bond wire to the board. So we have DFE over here, FFE, CDR, output data buffer, output clock buffer. And these are the IOs. Here's the test board. So this is the chip, and you have the 10 gig input data SMP, 2.5 gig reference clock SMP again. And so here's where you control the FFE coefficients with potentiometers. So I had the option to change the DFE coefficients also option. So you could use LMS, or if it didn't work, I had the option of controlling it off-chip with these 3 potentiometers. And these are all for power supplies, changing power supplies. And so I also had the option to bypass the CDR and apply the 10 gig clock off-chip, which I unfortunately didn't use, but I had that option. This is actually where those 10 gig input clock could come in. This is the 10 gig data output, and it's the 10 gig, this is the 10 gig clock output, recovery clock, and it's the 10 gig retime data. So here's a test setup. So I use a Jaybirds